Welcome to the course of Cryptography and Network Security. This is for 4th BTech first sem. So myself G. Prashanti, Vignan's Lara Institute of Technology and Science, Department of Information Technology. So in today's class, we will be going to study DES analysis, where in previous class we have seen what is DES and the structure of the DES and the key generation algorithm in DES and what is the function that is used in the DES. So in today's class we will be doing some analysis on DES, that is we will be studying what are the strengths of DES and what are the weakness of DES, and similarly what are the different multiple DES that we are having, and some introduction about the advanced encryption standard. Okay. So DES analysis, where the strength, coming to the strengths of the DES, the strength of our DES is the S boxes. Okay, so whatever the S boxes that we are having, that creates the confusion. Okay, confusion among the bits by substituting one set of bits with another set of bits, it creates a confusion among the bits. Okay, so that this S boxes design provides confusion of bits from each round to the next. Okay, since in each round we are using 8 S boxes. Okay, so that 8 S boxes produces a confusion among the bits in each round. Okay, and similarly we are having P boxes. Okay, so P boxes, they provide diffusion of bits. Okay, so whatever the straight P box, compression P box, expansion P box we are using, those produces the diffusion of the bits. Diffusion in the sense that, so it hides the relationship between the ciphertext and the plain text. So to hide the relationship between the ciphertext and the plain text, whatever the P boxes we are using, it provides the diffusion of bits. Okay, so the third strength of our DES is the number of rounds. Okay, so since in here in DES we are using the 16 rounds, where each round takes the function that consists of the P boxes and S boxes. Okay, and the XOR operation also. So here whatever the 16 rounds that we are doing, so that 16 rounds creates the ciphertext. Okay, so that 16 rounds creates ciphertext that is a random. Okay, so creates a random ciphertext that acts as a function of plain text and the ciphertext. Okay, what are the ciphertext that we are creating? That is a random function of plain text and ciphertext. Okay, so these are the 3 strengths of our DES, where the S boxes that provides the that provides the confusion. That means that it hides the relationship between the ciphertext and the key, and also P boxes that provides diffusion of bits. Okay, that hides the relationship between the ciphertext. Okay, that hides the relationship between the ciphertext and the plain text. Okay, and similarly number of rounds. So the greater the number of rounds, greater is the security that is provided. Okay, so and coming to the weakness of DES, so that some of the weaknesses are in DES okay, the weakness in DES is your S boxes. Okay, so here some researchers have been done some studies on these S boxes. Okay, so the researchers have studied these S boxes and they have given some weakness in these S boxes. Okay, so the literature, so they have gone through some study of these S boxes and they have given a literature of some weaknesses in these S boxes. Okay, so as we have said, in DES we are using the 8 S boxes. Okay, so 8 different S boxes. Okay, so in S box 4, the last 3 outputs. Okay, the last 3 outputs can be derived in the same way as the first output bit by complementing some of the input bits. Okay, so that is the weakness in S box 4, where the 3 output bits, whatever the 3 output bits, okay, the last 3 output bits can be derived in the same way as the first output bit by complementing some of the inputs. Okay, and the second weakness is that So specifically choosing two inputs to an SBox array can create the same output. Okay, so if we are choosing two inputs to an SBox array, it is creating the same output. Okay, so and the third is that it is possible to obtain the same output. Okay, so it is possible to obtain the same output in a single round by changing bits in only 3 neighboring SBoxes. Okay, if you take the 3 neighboring SBoxes, okay, it is possible to obtain the same output in a single round by changing bits in those 3 neighboring SBoxes. Okay, so these are the some of the weakness that has been found in the SBoxes. Okay, similarly coming to the P boxes also. Okay, so there are also some weaknesses that are found in the P boxes. So the first weakness is that the initial and final permutations. Okay, so whatever the initial and final permutations that we are using here in DES, so that has no security benefits. Okay, so it is like providing no security benefits. Okay, so and the second weakness is in the expansion permutation. Okay, so in the function f we are using the expansion permutation. Okay, so where the right bits are expanded to 42 bits. Okay, the right 32 bits are expanded to the the right 32 bits are expanded to the 48 bits. Okay, so that expansion permutation, whatever that we are using inside the function. Okay, so in that the first and fourth bits of every 4-bit series are repeated. Okay, the first and fourth bits of every 4-bit series is repeated. Okay, so that is the weakness in your expansion P box. Okay, and third one is the weakness in key. Similarly, there are some weaknesses in the key also. Okay, so the weakness in the key is its key size only. Okay, whatever the 56-bit key size we are using, so that is the key size is itself a weakness in the DES. Okay, so where here the attacker can do the brute force attack. Okay, brute force attack means that he will be checking all the possible keys. Okay, so here the attacker will be doing a brute force attack, which is nothing but checking all the possible keys. So here, since there are 56 bits, okay, so since here 56 bits, so here the attacker will be checking all the possible. Okay, so here the attacker will be checking all the possible 2 to the power of 56 keys. Okay, so he will be checking all the possible 256 possible keys on the ciphertext to derive the plain text. Okay, so that is also a weakness. In the DES, the key size. That is the key size is the 56 bits. Okay, so having only 56 bits in the key size, so the attacker can apply the brute force attack. Brute force attack means checking all the possibilities. Okay, so he will be taking 2 to the power of 56 and he will be checking all the 2 to the power of 56 possibilities of the keys on the ciphertext. Okay, so that is the third weakness that is found in the DES. Okay, so here since the weakness in the key, to overcome the weakness in the key, so to overcome the weaknesses in the key, so next is your next one is double DES. So where double DES, since the weakness of your DES is its key size. Okay, so since the key size is only of 56 bits, okay, the attacker can check all the possible 256 possible keys. Okay, so he will be applying all the possible 2 to the power of 56 keys on the ciphertext to get the plain text. Okay, so to overcome that brute force attack, so what we are having is the double DES. Okay, so where in the double DES, okay, given a plain text P, so in double DES, given a plain text P and 2 encryption keys K1 and K2. Okay, so here we will be using 2 encryption keys. Okay, so each key is of size 56. Okay, the K1 size is also 56-bit key size and the K2 is also 56-bit key size. Okay, so this enhances the security. Okay, so these two keys enhances the security of your DES. Okay, so K1 and K2 and a ciphertext can be generated as, so here, so you can generate the ciphertext like this. Okay, so suppose this P is your plain text. Okay, so P is your plain text. Okay, so P is your plain text where this plain text is encrypted with the key K1. Okay, so by using this key K1, okay, by using this key K1, okay, by using this key K1, the plain text is encrypted by using the DES encryption algorithm. Okay, by using the DES encryption algorithm, the plain text is encrypted with the key K1. So we will be getting a ciphertext. Okay, say the ciphertext is X. Okay, then this ciphertext is again encrypted. Okay, the ciphertext is again encrypted with the key K2. Okay, so the ciphertext is again encrypted with the key K2. So and then finally we will be getting another ciphertext. Okay, so here also DES encryption algorithm is used. So here we are applying DES encryption 2 times with 2 different keys. Okay, so first the plain text is encrypted with the DES algorithm with a key K1. So we will be getting a ciphertext. Okay, the ciphertext is again encrypted by applying the DES algorithm with the different key K2. Okay, so then whatever the ciphertext that we will be getting, so this will be your final ciphertext that is sent to the receiver. Okay, so coming to the decryption. Okay, so whereas coming to the decryption, so here the receiver, what the receiver has to do is that he has to take the ciphertext. Okay, so he has to take the ciphertext and then the ciphertext is decrypted by using the reverse cipher. Okay, so by using the reverse DES cipher, so I am using the key K2. Okay, so I am using the key K2 and the ciphertext is first decrypted by using the reverse cipher. Okay, so and then you will be getting some plain text X. Okay, so and then this, so whatever this plain text X that you are getting, so that is again decrypted. Okay, that is again decrypted with the key K1. So finally the receiver will be getting the plain text. Okay, so that is the equation that is given to obtain the ciphertext. Okay, to obtain the ciphertext, first we have to take the plain text. Okay, so first we have to take the plain text. That plain text is encrypted with the key K1. Okay, so first the plain text is encrypted with the key K1. So then you will be getting some ciphertext like say X. Okay, so that X is again encrypted with the key K2. Okay, that X is again encrypted with the key K2 to get the ciphertext C. Okay, so similarly to get the plain text. Okay, so here, so decryption is applied in the reverse order. Okay, so the decryption is applied in the reverse order where you will be taking the ciphertext. Okay, taking the ciphertext, you will be decrypting by using the key K2. Okay, so here you will be using the reverse DES cipher, and by that, so by decrypting with the key K2, you will be getting some plain text like some X. Okay, so this X is again decrypted with the key K1, so as to get the plain text P. Okay, so that is the double DES, so as to increase the security of the DES. Okay, since the key size of the DES is only 56 bits. Okay, so which is a weakness. To overcome that weakness, we will be using the two keys K1 and K2. Each key size is of 56 bits. Okay, so K1 key size is 56 bits and key K2 size is also 56 bits. Okay, so here the double DES, whatever the double DES we are having, that suffers from meet in the middle attack. Okay, even though it increases the key size, okay, even though the key size is increased, but here the double DES suffers from the meet in the middle attack. Okay, so here what is this meet in the middle attack? So what the attacker requires is that, so to do this meet in the middle attack, so what the attacker requires is that he requires some knowing ciphertext plain text pairs. Okay, he requires some plain text ciphertext pairs. Okay, so let us assume that we have a plain text ciphertext pair, that is we know the plain text P and its corresponding ciphertext C. Okay, so to do this meet in the middle attack, what the attacker requires is that the attacker requires plain text. Okay, so he requires a part of the plain text. Okay, so let the attacker knows a plain text P and its corresponding ciphertext C. Okay, he requires a pair. Okay, he requires a pair of plain text and ciphertext pair. Okay, so here let the plain text be P and the ciphertext C. Okay, so and then what the attacker will be doing, the attacker applies the brute force attack. Okay, so he will be applying the brute force attack on this plain text and ciphertext pair. Okay, so here let P be. So this P is the plain text and let C is the ciphertext. This P and C are the plain text and ciphertext pair. Okay, so what the attacker will be doing is that he takes the plain text P. So here he will be checking all the possible keys. Okay, since the K1 key size is only 56, since he is applying the brute force attack, he will be checking all the possible 2 to the power of 56 possible keys. Okay, he will be checking all the 2 to the power of 56 possible keys. With that all 2 to the power of 56 possible keys, he tries to encrypt this plain text. Okay, so here what the attacker will be doing is that by taking all the possible 2 to the power of 56 bit keys, okay, so 2 to the power of 56 keys, so he will be encrypting the plain text. Okay, so he will be encrypting that plain text and he will be moving in the downward. Okay, so similarly again here what he will be doing by taking that ciphertext C, okay, by taking that ciphertext C and the key, okay, and the possible 2 to the power of 56 K2 possible keys. Okay, so 2 to the power of 56 K2 possible keys, and this is 2 to the power of 56 K1 possible keys. Okay, with these K1 keys he will be encrypting the plain text. Okay, so and whatever the messages that he is getting after encrypting, that he will be taking. Okay, and similarly he will be taking the ciphertext and he will be decrypting that ciphertext with all the 2 to the power of 56 possible K2 keys. Okay, so he will be decrypting that C. Okay, so here in the middle, he will be meeting in the middle. Okay, since he is moving in the downwards and here he is moving upwards. Okay, since these two are in the reverse order, so at some point he will be meeting at the middle. Meeting at the middle in the sense that at some point this message M and this message M will be same. Okay, since this is and this is in the reverse order, since here the attacker is moving downwards and here the attacker is moving outwards. Okay, so in the middle, so this M and this M will be same. Okay, so and then so whatever the key, okay, with which key he has got this M and with which K2 he has got this M, those are the keys. Okay, so here the key K1 with which he has got this M and the key K2 which he has got this M, those are the keys for the attacker. Okay, so those are the keys, original keys. Okay, in that way he will be deriving the keys. Okay, by using this meet in the middle attack, the attacker will be deriving the keys K1 and K2. After he derives the keys, okay, after he derives the keys, he can easily decrypt the ciphertext. Okay, so and after getting all the keys K1 and K2, he will be decrypting the ciphertext and he will be getting the plain text. Means that the attacker has succeeded in achieving the plain text. Okay, so that is the meet in the middle attack. Okay, so here what he will be doing is that he will be taking the plain text and ciphertext pair. Okay, so here he will be encrypting this plain text with the key K1. Okay, so he will be noting all the K1 possible keys, 2 to the power of 56 possible keys. Okay, so he will be taking the 2 to the power of 56 all possible keys. Okay, with each key. Okay, so with each key, so he will be encrypting this plain text. Okay, so he will be encrypting this plain text and he will be recording in this table. Okay, similarly here also what he will be taking is that he will be taking all the 2 to the power of 56 possibilities, like so k21, k22, okay, in that way all 2 to the power of 56 possibilities. Okay, so all these possible keys for each key. Okay, so here with each key he tries to decrypt this ciphertext. Okay, with k21 he is trying to decrypt this ciphertext. So he will be getting some m21. So similarly with k22 he will be trying to decrypt. So again he will be getting some m22. So similarly here also. Suppose the key is k11. Okay, one possible key is k11. With this k11 key he tries to encrypt this message. So he will be getting some 11. So similarly with k12, with another possible key k12, he will be encrypting this plain text. So again he will be getting m12. So in that way he will be writing all the 2 to the power of 56 messages with all the k to the power of 56 possible keys. Okay, so here, so that is the first step. So here what he will be doing, he will be encrypting P, okay, encrypting P using all possible values of K1. Okay, using all the possible values of K1, he will be encrypting P and records all the values obtained for M. Okay, so and then he will be storing all those values in this table. Okay, so and similarly, okay, so he will be decrypting C with all the possible values of K2 and records all those values obtained for M. So for similarly for K2 also he will be recording all the values. Okay, so and then the two tables are created and are sorted by M values. Okay, after that he will be sorting these two tables. Okay, so now when he compares the two values of M, after sorting, when he compares the two values for M, he will be finding pairs for K1 and K2 for which the value of M is same in both the tables. Okay, since the encryption and decryption is in the reverse order, so ultimately there will be some M value here and then some M value there, so that are equal. Okay, so he will be finding which M value is equal. Okay, the value of M which is equal, then he will be taking the corresponding K1, K2 values. Okay, so here so he will be comparing the two tables for some M value to be equal. Okay, so so since both are in reverse order, both encryption and decryption are in the reverse order, so ultimately there will be some M value. Okay, there will be some M value which will be equal. Okay, so and then he will be taking the corresponding K value. Okay, so and then he will be taking the corresponding K value. Okay, so this corresponding K value will be your K1 and this corresponding K value will be your K2. Okay, so in that way he will be obtaining the keys K1 and K2. Okay, once he gets that keys K1 and K2, so he will be trying to decrypt the ciphertext. Okay, and he will be achieving the plain text. Okay, so that is the meet in the middle attack. So to overcome that meet in the middle attack, we are having triple DES. Okay, so where in triple DES, this triple DES is to overcome the attack of meet in the middle. Okay, so here we will be using two keys. In triple DES we are using two keys. Okay, so where we will be taking the plain text P, okay, taking the plain text P and encrypting. Okay, we will be taking the plain text P and the key K1. Okay, so again the size of this key is again 56 bits. Okay, so taking the plain text P and the key K1. Okay, so we will be again applying the DES. Okay, we will be applying the DES encryption. Okay, so we will be applying the DES encryption on this plain text P. Okay, with the key K1. So we will be getting a ciphertext A. Okay, so some ciphertext A is achieved here. Okay, so this ciphertext A is again decrypted. Okay, so this ciphertext is decrypted with key K2. Okay, so this ciphertext is decrypted with key K2. So he will be getting some plain text B. Okay, so again this plain text B is again encrypted with the key K1. Okay, so finally the ciphertext which we will be getting is the final ciphertext. Okay, so here we will be using one DES encryption and then decryption, DES decryption, and then again DES encryption. So finally we will be getting a ciphertext, but the keys are different here. Okay, so similarly to do the decryption, okay, so to get the plain text, okay, so to get the plain text from the ciphertext, okay, what the receiver will be doing is that he will be taking the ciphertext and with the key K1, okay, so with the key K1 he will be decrypting, okay, so he will be decrypting the ciphertext with the key K1, so he will be getting a ciphertext B, okay, so again this ciphertext B is again encrypted. Okay, it is again encrypted with the B to get the plain text A. Okay, so and then again this is decrypted with the key K1 to get the plain text B. Okay, so that is the triple DES with two keys K1 and K2. So where we will be first doing the encryption on the plain text and then the decryption and again encryption with keys K1 and K2. Okay, so again to achieve the plain text, so again we will be doing a decryption with the key K1 and then again we will be doing encryption with key K2 and then again decryption with the key K1. Okay, so in that way the triple DES. So this triple DES so overcomes that meet in the middle attack. Okay, so that is about the DES. Okay, so if you see, if you compare your okay, so if you compare your double DES and triple DES, so see here, so in double DES, what is having in the middle, you will be getting the same value. Okay, so in the middle you will be getting a same value where but this moving along this you will be getting X and moving along this also you will be getting the X value. Okay, so this X, middle X value is omitted, it can be avoided, this middle X value can be avoided by using the triple DES. Okay, so this is avoided in your triple DES. Okay, so see here, this is meeting in the middle can be avoided in the triple DES by using the decryption and encryption. Okay, so by doing the decryption with K2 and by doing the encryption with the key K2, so that meet in the middle attack can be overcome by using this triple DES. Okay, so that is about the data encryption standard where we have seen the algorithm for the DES. Okay, where we have seen the DES structure, function of the DES, what are the S boxes that having in the DES, what are the P boxes, number of rounds in the DES, and similarly what are the strengths of the DES. Okay, so in DES analysis we have seen what are the strengths of the DES and what is the weakness of the DES. Okay, and similarly so to overcome that weakness, okay, so one weakness of our DES is its key size. Okay, to overcome that weakness, to overcome that key size weakness, we are going with the double DES. Okay, but here where in the double DES we will be using two keys K1, K2, each of size 56 bit. Okay, so but the drawback in the double DES is that it suffers from the meet in the middle attack. Okay, to overcome that meet in the middle attack, we are having the triple DES. Okay, so that is about the data encryption standard. Thank you.